Hello. So I've come up with the idea of making a new series for the first year MBBS and the students who are preparing for their MLE or PLAB exams. And the goal of our video is to gain the maximum concept and to retain the maximum information with the techniques. So we start off by embryo. So let's get started. Try to stick with me throughout these videos, even though you think if it is too basic for you, because everything will revolve around these topics. So we start off by chromosome theory of inheritance, and first we have definition of genes, and genes are sequence of DNA on chromosomes. Then chromosome structure in nucleus that contains DNA. Then we talk about somatic cells, any cells in the body except germ cells. Then we have diploid, it is 2n, 46 number of chromosomes, pair of chromosomes basically. Then we have haploid, 1n, which is 23 chromosomes, not a pair. Next we have definitions of autosomes, all chromosomes except sex chromosomes. And sex chromosomes are X and Y chromosome. Oocyte is maternal gamete, it is haploid. Sperm, a paternal gamete from father, it is haploid. Fertilization, gametes unite, restore diploid cell, which is 46 chromosome 2n from haploid and haploid. Then we start off by mitosis, and one thing you should remember as a medical student that diploid cell forms two diploid cells and haploid cell will form two haploid cell, and it is in mostly diploid cells. So same cell as the parent cell. So it has phases, interphase, prophase, metaphase, anaphase, and telophase. Then we talk about meiosis, and in meiosis, the two end cells makes one end cell. So diploid cell makes a haploid cell. So we have the example of spermatogenesis, which we will discuss later in detail, where haploid spermatozoa form, and oogenesis, which we will discuss later, which forms ovum, which is also haploid. Two things are important that in meiosis 1 there is crossover, and in meiosis 2 there is reduction where the diploid forms a haploid cell. Then there is difference between mitosis and meiosis, and in mitosis, diploid cell forms a diploid daughter cell, whereas in meiosis, diploid cell forms a haploid cell. Next is the most important part of this video, and try to take down notes if you can. So we have chromosomal abnormalities, and we have numerical as well as structure abnormalities. For numerical abnormalities, we have the normal diploid cell, normal haploid cell. Euploid is same multiple of the number n is 23 either, and 2n makes 46. Aneuploid is not euploid. So if one extra chromosome trisomy, we have 47 chromosomes, so we cannot multiply it with any number, or in monosomy we have one less chromosome, 45, so we cannot multiply it with any number. Then we will continue with the non-distinction of meiosis, and this is important. No separation leads to trisomy and monosomy, which I will explain later. Then is non-distinction in mitosis, which is not as important. So we have mosaicism, in which some cells of the body are affected. Then we have translocations. The chromosome piece breaks down and attaches to the other chromosome. It can be balanced, where no critical genetic material is lost, or unbalanced, in which critical genetic material is lost. And there is an altered phenotype. From this, the most important thing starts. Look at the karyotyping of the diploid cells. Here we have one pair of chromosome 1, chromosome 2, chromosome 3, up to chromosome XY, which is the 23rd chromosome. And this is the haploid karyotyping. There is one single chromosome 1 and one single chromosome 22 and one single X chromosome. Next, we talk about the non-disjunction in meiosis, and as we saw, there is a haploid cell from a diploid cell at the end of the meiosis too. In the case of non-distinction, there occurs an extra piece of chromosome, and the chromosome number alters. Either it becomes less than usual or it becomes more than usual. When normal haploid cell combines with the non-distinction product of meiosis, it leads to a altered number of chromosome, which is not normal. So here we have 47 in the case. So in case of Down syndrome, which we will discuss in a moment, is the trisomy 21, in which there is an extra chromosome here, and which comes along with the normal chromosome here, and it forms one extra chromosome, and there is trisomy 21 here we have. Next is the numerical abnormality, and the first one we have is Down syndrome, and this is trisomy 21. So the mnemonic for the Down syndrome is D. For D we have die, which is 2. For O we have 1, which is 1, 21. And for W that looks like 3. We have trisomy. So trisomy 21 is Down syndrome. Next are the features of Down syndrome, and we have the mnemonic Down child has problems. And for the word down, we have decreased alpha fetoprotein. For O, we have one extra chromosome, that is 21 trisomy. For W, we have women age maternal. If less than 25, we have 1 in 2000 defect. If 35 years of age, we have 1 in 300, and in 40 years of age, we have 1 in 100. This one is very important from examination point of view, so please remember it. For the N, we have non-distinction in meiosis, which we have already discussed. For the next word, we have child, and for C, we have cardiac defect or craniofacial abnormalities. For H, we have hypotonia. For I, we have nothing. For L, we have leukemia. For D, we have duodenal atresia and developmental delay. H, we have Hirschsprung's disease. A, we have Alzheimer's. S is for slanty eyes, like this, slanty eyes, and single palmar crease, which is also called simian line. It is a single palmar crease. Normally, we have two palmar creases. And for problem, we have palpebral fissure upslanting. That is same for this one. So this is the picture of a child with Down syndrome, and you can see there is palpebral fissure and slanting of eyes and craniofacial abnormalities. Then we talk about trisomy 18, and 18 starts with E, and for E we have Edwards syndrome, and in this we have everything low. So low mental function, that is mental retardation, low set of ears, low jaw, undersize like this, there is micrognathia. For low kidneys, we have renal anomalies. For low finger count, we have syndactyly fused fingers, so finger count is low, and lip is cleft, so there is a hole in the lip. Only one thing is prominent in this, and that is occiput. The posterior part is prominent. Next, we talk about trisomy 13, and for trisomy 13, we have name Patau. So in Patau, the T word is for 13. So we have C and M for the defects. For C, we have congenital heart defects and cleft lip. For M, we have microcephaly, holoprosencephaly, more fingers. That is polydactyly. Next is Klinefelter syndrome, and for K we have King, and this occurs in males only. And there is XXY chromosome, 47 number of chromosome with XXY or XYY. XXY is the most important for MCQ's point of view. For L we have low hair. For T, we have tall body. For R, we have bar body, which is XXY, one extra body, that is bar body. And for S, we have small testes as they are underdeveloped. So here is the picture of Klinefelter. You can see there is tall stature with developed breast, and there is poor bone growth and very low hair on the body. Then we'll talk about structure abnormalities, and in this chromosomes break or delete. There can be partial or micro deletions. First we have is Cri-du syndrome, and this is partial deletion. So Cri-du are 5 letters, so we have chromosome 5, and chat is cat like cry. You can see the cat here, and there is microcephaly and mental retardation. Next we have is Angelman syndrome, and if you count the letters of Angelman, we have 15 letters if you exclude the O of the syndrome as 0. So we have 15 letters, and this is on chromosome 15 maternal. So mothers are for the angels, and there is unprovoked periods of laughter. Here you can see the kid is laughing, and this is the picture from the Langman. There is also mental retardation, and this is microdeletion. Next is Prader-Willi syndrome. So for Prader-Willi syndrome, you write a 1 like this, and with that you write a P. So for 1, we have 1, and for P, we have 5, which is penta. So for P, we have paternal. So 15 chromosome on paternal. For this, we have mnemonic OGI. So for obese, OGI was obese. For G, we have gonad dysfunction, which is hypogonadism, and then there is mental retardation like OGI who was mad. Here is the picture of patient with Prader-Willi syndrome. Next is Fragile X syndrome. For F, we have FMR1 gene. For R, we have repeat C, G from here and G pattern. For G, we have giant testes. For L, we have large ear. and large prominent jaw. Next are gene mutations, which we will discuss later. These are autosomal dominant or recessive inborn metabolism disorder. And for diagnostic techniques, you should remember the name of Giemsa stain, which is used, and FISH technique, which is fluorescence in situ hybridization.